Hi guys, so now that we've seen an introduction to what polar graphs look like and polar coordinates, we're going to look at how to draw polar graphs without a calculator. So what we're going to do here is we're going to identify the type of graph that we have based on the equation, and then we're going to use what we know about exact values to plot some points on this graph to get a good picture for us. Alright, so the first thing that we're going to do, this first picture here, if you recognize that, that is a circle, okay? So we know that's a circle, and that's not the kind of circle like r equals. So that's a circle that's going to be either horizontal or vertical. It's going to go through the pole, and the number in front we know is the diameter. So it's not something like r equals 4, which looks like this. That's not the kind of circle we're dealing with right now. Now what we also can tell from looking at our equation, before we even plot points, you may be able to draw a graph here. If you recognize that this is cosine, we know it's going to be horizontal. And since there's that negative out in front, we also know it's going to be on the opposite side. So I know that circle is going to be somewhere over here. If you really remember a lot about this, you may remember that the number in front corresponds to the diameter. And if that's the case, then I could actually go ahead and make this circle without plotting any points. It's just going to look like that. And yours will probably look more like a circle than mine does, but that's the same idea here. Now let's say you don't remember that the number in front corresponds to the diameter. Then what you can do is you can plot points. And that's what we're going to do for the majority of these graphs. So we're just going to make a table. Similar to what we did with x and y, we're going to make a table where we're going to use theta and r instead of x and y. So what I'm going to do is I'm going to pick theta values to plug in and then graph the corresponding r value. So the first theta value I'm going to look at, we'll take some easy ones here, like 0. Okay, so if I plug in 0, I have negative 4 times the cosine of 0. Well, we know the cosine of 0 is 1, so this just becomes negative 4. Then if I plug in pi over 2, negative 4 times the cosine of pi over 2. The cosine of pi over 2 is 0. Anything times 0 is 0. Then if I plug in pi, negative 4 times the cosine of pi. The cosine of pi is negative 1, so this is a negative 4 times a negative 1, which is positive 4. So we can go ahead and plot these points because it'll give us a good picture of what this circle is supposed to look like. Just remember, we're graphing thetas and r's. These are not x, y coordinates, okay? So what I'm not going to do is go to 0, negative 4, and plot a point down there. That's not the case here. I'm going to go to 0 degrees, and I have a radius of negative 4. So a radius of negative 4, remember, means I'm going backwards 180 degrees. So I'm going back this way 4 degrees. So I'm going to plot that point 4 away from the center, 4 away from the pole. Then the next point, at pi over 2, I have a radius of 0. If the radius is 0, that point goes through the pole. Then if I go to the angle of pi, then I'm plotting an r value of 4. I already have that point plotted. Okay, what that tells me, it's already there. This circle, actually, you don't need a full 2 pi radians to graph the entire circle. This circle is actually going to be graphed just by going from 0 to pi. You'd get the full circle. And that's a pretty terrible circle drawing there, but you know what a circle is supposed to look like, so you can pretend that it's a perfect circle that went around the points it's supposed to go to. Alright, so let's move on to something that's not a circle. Let's look at this next one here. Now we know from that format, since the number in front, okay, the 2, the a value is smaller than the b value, this is going to be a limacon, but it's a limacon with a loop because the number in front is smaller. So we know there's going to be a loop here. We also know because it's sine that it's going to be vertical. Alright, but again, to get an exact picture of what this graph looks like, now we know the general shape, it's going to go up and have a loop and something like that, but we don't know exactly what points it's going to go through. That's where that table is going to help us. Alright, so that table, I have theta values that I'm going to pick that are going to give me corresponding r values. So some theta values again, if I try something like 0, pi over 2, pi and 3 pi over 2, those would be some good points to start off with. So if I plug in 0, the sine, I'm doing 2 plus 3 times the sine of 0. The sine of 0 is 0, so I have just 2. Then I plug in pi over 2. So 2 plus 3 times the sine of pi over 2. Well, the sine of pi over 2 is 1. So I have 2 plus 3 times 1, which is 5. So I'm going to go ahead and plot those 2 points. At 0 degrees, I have a radius of 2. At pi over 2, I have a radius of 5. Then I go to pi. So 2 plus 3 sine pi. Sine of pi is 0, so I just have 2. And then finally 2 plus 3 sine 3 pi over 2. Sine of 3 pi over 2 is negative 1. So I have 2 plus 3 times a negative 1, which gives me a value of negative 1. So let's plot those last 2 points. Pi 2, I go to pi degrees and a distance of 2 away. Now the last one is where basically the reason we get our loop. If you look at 3 pi over 2 and negative 1, if I go to the line 3 pi over 2, then instead of actually plotting anything on that line, I have a negative radius. So I have to go backwards a distance of 1. So that point is actually going to be plotted here. And you can see the reason that we have a loop here is because we get those negative values when the a is smaller, forces us to go backwards inside the graph, and that's why we end up with a loop. So this graph is going to look something like that. Now mine's not perfect by any means. Just know that this graph does go through the pole, okay? And also that you have some points below here. Now if you want to find what those are exactly, you're welcome to plug in more points. They're not going to give you nice, pretty exact values though. If you were to plug in something like pi over 3 and pi over 6, you would get values that have, your root 3s and your 1/2 and things like that. All right, but this is enough for us to get a good picture. Now you'll also see some questions in class about things about the graphs, like where do the loops and things like that. Now this is something we could find exactly if we wanted to, but I'm more concerned with you guys understanding how this works. Now the loop begins and ends here at that same point, and if you notice that point is the pole. So what we need to understand is that the loop begins and ends at the pole, and the pole is when the r value is equal to 0. So if you wanted to actually solve for what those values were, you would take your original equation, and I would plug in 0 for r, and I could actually solve for that. Now I'd have to use a calculator to solve for this one, because it would end up with a negative 2/3, and that's not an exact value that I can find, but it would be possible to find it if I wanted to. What you also know about inverses is that if I do sine inverse of any value, there's also 2 answers. One answer would be where that loop starts, the other answer would be where that loop ends. Alright, so we're going to look at another different shape here. Let's look at some of our roses. Okay, so we know a graph in this form is a rose. It's an even number for my petals, so since it's an even number, it's twice as many, so this rose is going to have 4 petals. And if you remember that number out in front, okay, the number out in front is the size of the petals. Now I'm going to go ahead and make that a bigger number just so it's a little easier to see here. I'm going to go ahead and make that 6 out in front just to make this graph a little easier to see. Okay, now a 4-petal rose, what I'm going to do is make my chart again. But the problem this time, whenever I do my roses, is if I just pick these same basic values, it's not going to be enough for me to get a clear picture of what this graph looks like. If you plug these in, you'll see what happens. So if I plug in 0, that's 6 sine of 2 times 0, which is 0. The sine of 0 is 0, so this gives me a value of 0. If I plug in pi over 2, I'm doing 6 times the sine of 2 times pi over 2, which is pi. The sine of pi is 0, and 6 times 0 is 0. If I plug in pi, I'm doing 6 times the sine of 2 times pi. The sine of 2 pi is the same as the sine of 0, which is 0. So you can see the problem we have here. Every value of those four angles is going to give me an R value of 0. So I'm not going to be able to plot any points at those angles. I'm only going to have a point here. Alright, so in order to see a better picture of what this graph is actually going to look like, I'm going to pick some R values that'll be a little easier to work with. Now you can choose whichever R values you want, but what I'm going to choose is something that's going to give me a nice, easy to work with number here inside. So for example, if I pick pi over 4, then I have 6 times the sine of 2 times pi over 4. And you guys can see the reason I picked pi over 4, it reduces to pi over 2. Now I'm still finding one of my exact values, one of those easy values, but it's a little bit easier just to see this way. So I'm doing 6 times the sine of pi over 2. The sine of pi over 2 is 1. 6 times 1 is 6. So at pi over 4, which is right here, halfway between pi over 3 and pi over 6, I'm going out a distance of 6. Alright, if I want to see another picture, another petal in that rose, let's try 3 pi over 4. Another pi over 4 value. Okay, that's going to give me 6 times the sine of 2 times 3 pi over 4, which is 6 pi over 4. 6 pi over 4 is 3 pi over 2. The sine of 3 pi over 2 is negative 1. So 6 times negative 1 is negative 6. So at 3 pi over 4, that's this angle right here, I'm going backwards 6. So now my petal's over here. And if you were to continue, you would get another point here and another point here with those other angles. So that'll help you see what your rose is going to look like. So my rose looks something like that. Now, if you remember a lot about what we looked at yesterday with these graphs, you may have remembered that the sine graphs don't go through those points. If you did notice that, then you probably could have drawn this without plotting points. But if you don't remember things like that, that's when it's good to help us plug in points to get a clear picture here. Now, if you think you understand for the most part what's going on here, you can go ahead and shut the video off because you've seen enough at this point. But I am going to do one more example if you want to see another one of these roses, figure out how to pick those points when we can't pick the nice, easy on the border points. Okay, so let's look at this last one. This is, again, a rose. Each petal is going to be a distance of 3, and it's an odd number, so it's the same. So this is going to have 5 petals. So this is a rose with 5 petals. Now I can start with my theta R chart. Or if you remember, again, the difference between the sine and cosine graphs, that cosine 1 is always going to have a point somewhere on this line. Okay, but to figure out if you don't remember that, if you're not sure, plug in that value. Let's plug in 0 and see what we get. So if I plug in 0, that gives me, I'm going to move this over so I have a little bit more space. So if I plug in 0, I'm doing 3 times the cosine of 5 times 0, which is 0. So 3 times the cosine of 0 is 3 times 1, which is 3. So at 0 degrees, I have a distance of 3 away from the center. Okay, so I know I'm going to have a petal there because it goes through that point. 3 is the furthest that it could go. Now at this point, to work this out perfectly, it doesn't need to be 100% perfect for what we're doing in here. But what you need to do is be able to recognize that this is a petal, or this is a rose, it is going to have 5 petals, they are going to be a distance of 3, and then one of them is located here at 0. Now there's 2 things we could do if we wanted to make this graph a little bit more perfect. We could actually pick the theta values that are going to give me exact values. For example, if I were to pick the value pi over 5, by picking pi over 5, that gives me 3 times the cosine of 5 times pi over 5, which we know is just pi. That means that I'm doing 3 times the cosine of pi. That's one of my nice easy values to find, which is going to give me a distance of -3. That means at the angle pi over 5, I have a radius of -3. Now the reason though we don't want to worry too much about this and stress too much about this is that's not an easy value to graph. If you look, your pi over 3s, your pi over 4s, your pi over 6s, those are easy. But pi over 5, that one's a little bit harder. We know that if this is pi over 4 and this is pi over 6, we know it's going to be in there in the middle. But we don't know exactly where it is. We don't use it a lot. And also I have to go backwards from that point too. So it's not even just graphing that point. It's graphing 180 degrees away from that point, a distance of 3. So one of those petals is going to be over here. But a distance of 3. That wasn't a very good drawing there. So what we can do instead when it comes to some of these roses, we know one of those petals is going to be here on the x-axis. So what we can do instead to make this a little bit easier and a little bit, but still slightly accurate, is let's just try and space those petals out evenly. Okay, so I know I have to draw 4 more petals, so we'll have 1 petal in each quadrant. So I'll have 1 here, 1 here, and 1 here. And that's a terrible, terrible drawing, and some of those are a distance of 4 and a distance of 3. So they need to be a little bit better than a little bit of a better picture. But you get the idea. We know that there's going to be 5 petals. We know they're going to be evenly spaced. So I can just draw them in somewhat similar without making it completely perfect and finding the exact angle. Alright, so that is how we graph our polar equations when we don't have a calculator. So we'll do some practice on this. And again, if you're not sure what these graphs are going to look like, there's never any harm in picking some theta values, plugging them in, and then just seeing what happens.